So this is unit 2.2, and we're going to break this into 2 or 3 sections. But part 1 is what we're going to go over today, and our objectives for today are the student will be able to, and there's 4 things we want to be able to get out of this. We want to be able to identify the parts of a quadratic function that are written in standard form. And we'll go through standard form in a little bit. We want to be able to find the axis of symmetry. Remember, you did axis of symmetry in geometry. If I have a parabola, an axis of symmetry is going to go through that so that if you folded it over, it matched up. And so it has to pass through the vertex. So that's what the axis of symmetry is. And we know what the vertex is. That's our turning point. But we have to learn how to find that. And then we have to find the maximum or minimum of a function. And the maximum or minimum of a function, when you have a parabola that opens up, it goes up forever, but it has a lowest point. So this would have a minimum and not a maximum. But if I had a parabola that opened down, then it would have a highest point, and that would be at the vertex, because it would go down forever. So we're going to learn how to find those as we go through this today. So standard form. Standard form is when I write it in the form of ax squared plus bx plus c. And again, if that was a function, it would be f of x equals ax squared plus bx plus c. And the only restriction is this is a cannot equal 0. Because if a was 0, then it would make this x squared disappear and we'd have a linear function and not a quadratic. So to find the axis of symmetry, that's found by using the equation x equals negative b over 2a. And you'll understand why we're using this in a minute. But that's the formula we use. And then the part that causes some confusion for people is the vertex. And the vertex is this negative b over 2a, because remember, if we think of our parabola, we have this axis of symmetry, which we have said the axis of symmetry, which we'll abbreviate AOS, is x equals negative b over 2a. Well, this vertex here, the x value of that is whatever that axis of symmetry is. So that's why the vertex is this negative b over 2a. And then this is what causes people some confusion, this f of negative b over 2a. All that means is you're taking this value for x, because remember this is our xy, and we're taking that value of x that we get here in the vertex, and we plug it into the function. That's why it says f of whatever that value of x is, we plug in, and whatever we give out, because remember this is our y value, when we put this value in, whatever we get out is our y value, so that gives us our vertex. And I think this will really clear up as we go through some problems. But what I'd like to do is go through how this is derived from our vertex form, which we worked with on 2.1. Remember, the vertex form was a times x minus h, not absolute value, a times x minus h squared plus k. So we're going to go from how we get from here, how we get to standard form. And they do a good job of explaining that in the book. And so this is on page 56, so if this is difficult to see, please open your textbook on the computers so as we go through this you can see it. But we've got vertex form. Okay, I'll write that here a little bigger. X minus h squared plus k. And so what they do is they take this x minus h squared and go x minus h times x minus h and FOIL that out. And so we get this a times x squared minus 2hx plus h squared, and then plus k. And then they just distribute that a through to everything. So we get ax squared minus 2ahx plus ah squared plus k if they multiply that all the way out. Then what they do is they just group this. So they group this 2ah and they group this ah squared plus k, that's something that doesn't have. So they have the a, so you can see the a didn't change from our vertex form to our standard form. They're just going to replace this minus 2AH, and we're going to say that's B. And so they're going to put plus B here. Okay? And then this AH squared plus K is a constant value because there's no X in that. And so they just change that to C for constant. So, as we go through this then, what happens is the A is A in both. It has the same meaning in vertex form as standard form. It tells us whether it's being vertically stretched or vertically shrunk, or if it's being reflected over the x-axis. Nothing has changed on that. But we're letting this B equal negative 2H. Well, if B equals negative 2AH, sorry, and we solve for H, we would divide by negative 2A. And so that's where we get this negative B over 2A. It's the same as H. And remember, H is our vertex in standard form. And then this AH squared plus K is our constant. And what that gives us is that if we put 0 in to this standard form, if I put 0 in for X, that gives me 0 plus C. And so when I put in f of 0, I get this C value. Well, if you think about a graph, if I take this function here, when x is 0, that's this point here, which is our y-intercept. So that tells us that the y-intercept is C. And so it's not important that you can do this. It just shows us where this axis of symmetry is negative B over 2A comes from, and then how we get the K value, because we're just plugging in that X value into the function. So if we go back to the notes, so what I'm going to do now is I'm going to go through several examples of how to find the axis of symmetry in the vertex. And you can stop this at any time. Once you feel you understand how to find the axis of symmetry in vertex, I would pause the video and try one on your own, and then check it to see if you come up with the same answers that I do, because I'll go through all of these. So the first thing I would advise doing to cut down mistakes is, first of all, tell what your A is. And so in this case, our A, remember, is the number multiplied to x squared, so that's 3. Our B is the number multiplied to x, and so that's 6. And our C is the value by itself, our constant, so negative 7. So now we're going to find the axis of symmetry. And remember, the axis of symmetry is negative B over 2A. So I'm just going to find the axis of symmetry. I take the opposite of B, so that would be negative 6, divided by 2 times 3, which would be 6. And so that's negative 1. And again, I'm just going to abbreviate that. The axis of symmetry is, and you always want to put X with this. X equals, because remember that axis of symmetry is a line at the value of X. So in this case, our axis of symmetry is negative 1. Now we need to find the vertex. So remember, the vertex is, we know the X value is negative 1. And so now we just plug that negative 1 in. So negative 1 squared is 1, and 3 times 1 is 3, plus 6 times the negative 1. And so that would be negative 6 minus 7. So 3 plus negative 6 is negative 3, minus 7 is a negative 10. And so now we have the vertex at negative 1, negative 10. And that's all you're doing to find the axis of symmetry in the vertex. So on number 2, so again, the first thing we're going to do is I'm going to determine what A, B, and C are. So A in this case is negative 2, B is 6, and C is 5. Okay? Now we plug it in. So this would be the opposite of B, would be negative 6, divided by 2 times 2 would be a negative 4. And so we get 3 halves. And so our axis of symmetry is x equals 3 halves. And our vertex is, we have to plug in 3 halves. Now, I don't care if you use fractions or decimals. You can use 1.5. Doesn't make any difference. I'm going to go ahead and use a fraction. So I'm going to plug in 3 halves here, so I get -2. If I square 3 halves, remember you square the top and bottom, so that would be 9/4 plus 6 times 3 halves plus 5. So now that I have these values, I'm going to multiply. You can go -2 times 9. I like to cancel. 2 goes into 4 twice, so that gives me a -9 halves. Plus 6 times 3 is 18 divided by 2 would be 9. Or you can go 2 goes into 6 3 times, and 3 times 3 is 9. Plus 5. And so again, I don't care if you use fractions. This one's pretty easy to do as a decimal. That would be -4.5 plus 9, which would be 4.5 plus 5 would be 9.5. So we have 3 halves and 9.5, and we're done. So, the next one. Again, stop at any point and try one on your own, and if you understand it, you wouldn't need to do any more. So again, we're going to do our values. A is, now if there's no number in front, it's considered to be a 1. B is 4, and C is -12. So, -b, so -4 divided by 2 times A, 2 times 1 is 2, and so -4 divided by 2, so our axis of symmetry is x equals -2. Always want to put that x equals. And now we plug in -2 for our vertex, and we substitute in and we find the value of y. So if we go -2 squared, that would be 4. 4 times the -2 would be -8 minus 12. So we get 4 minus 8 is a -4 minus 12 is a -16. Next one. A is, again, 1. B is 3. C is -2. B, so that would be -3 over 2 times 1, which is 2. So we're back to a fraction. So our axis of symmetry is x equals -3 halves. So now we can do the vertex. We put -3 halves in for x. Again, you can do that as a decimal. I'm just going to go fraction, 9/4. 3 times -3 halves is a -9 halves minus 2. Now, when you're doing fractions, remember you have to have a common denominator. So I'm going to change all of these to fourths. So the first one's going to stay the same. Since I have to change that to fourths, remember what you do is you say, oh, I have to multiply 2 by 2 to get to 4, so I multiply the top by 2, so that's 18. Now this, there's no number underneath it, so it's a 1. I have to multiply 1 by 4, so I multiply 2 by 4, and I get -8/4. 9 minus 18 is a -9, minus 8 is a -17, so we get -17/4. Now again, if you wanted to use a decimal, that'd be -1.5 and -4.25. Either way, doesn't make any difference. Should work both ways on the computer. So the last one. So hopefully this is kind of making sense now. If you take a look at this last one, it says, let's get our A value, -3. B is 18, and C is 10. So we do -B divided by 2 times the -3 would be a -6. And so that gives us our axis of symmetry as x equals 18 divided by 6 is 3. 2 negatives is a positive. So we get x equals 3. And now we simply, for our vertex, plug in 3. 3 squared is 9. 9 times negative 3 is negative 27. 18 times 3 is 54. Plus 10. Negative 27 plus 54 is 27. Plus 10 is 37. And so we found our vertex at 337. So that's what you're doing on the first part of the assignment, is you're finding the axis of symmetry and the vertex. And it's simply finding the values of a and b and plugging them into the formula. Negative b over 2a to get the axis of symmetry, our x value. That gives you your x value of the vertex, and then you resubmit that back in to solve for y to get your vertex. So hopefully that makes sense, and it's just finding the values and plugging them into formulas. The last thing you're going to do is the maximum or minimum value. And the book goes through a really nice example of this on page 58 in their core concept. So we're going to go to that. Get rid of this. All right. So, course concept on page 58 on the maximum minimum. We talked about where that is. Okay? So here we have a parabola that opens up. And remember, we can tell that by the a value. If the a value is positive, greater than 0, then our parabola opens up. And therefore, we have a minimum value, a lowest value. It goes up forever. If a is negative, less than 0, then it reflects over. And that's going to have a maximum value because it has a highest point and it goes down forever. So, the maximum or minimum value is always at the vertex, and it's the y value. So they do this f of negative b over 2a. So again, all you do is you find that axis of symmetry, and you plug it in to find the y value of the vertex. So all these are the minimum and maximum values are the y value of the vertex. So you just find the vertex like we did on the original problems that we just went through, and then you'll know the maximum or minimum value of the function by the y value. Now, domain and range. You should have worked with this in algebra and probably geometry, but as a review, the domain is your x values. What can you put in? And the x values for all of these, because the x values, I can put anything in for x. There's no restrictions on what I can put in for x. So the domain on all of these will always be all real numbers. The range, though, is your y values. And your y values, in this case, like if this vertex, let's say it was 1, 2. Then the y values would start at 2 and increase, and so our range would be y is greater than or equal to 2. You just go by the vertex, so the y value. If it opened down, let's say this was 1, 4, then my y values start at 4 and they go down from there. There's nothing bigger than 4. So we would say y is less than or equal to 4. And then the last thing they're going to ask you to do is describe when this graph is increasing and decreasing. And so again, this is pretty easy. If it's going down as it comes to the vertex, you just say it's decreasing to the left of this negative b over 2a, so your x value of the vertex. So we would just say this is decreasing to the left of x equals, in this case, 1. And it's increasing once it gets past the vertex, so it starts going up. So when x is equal to 1, to the right of that, it's going to be increasing. When we do this one where it opens down, it's increasing as it comes to the vertex. So we're going to go, it's increasing to the left of 1. And it's decreasing once it gets past 1. So to the right of 1. So that's what you're going to be doing on the last assignment. So without going through and finding the vertex on problems, because you already know how to do that, we can just go back to the problems we just did. So I'm going to go back to these 5 problems, and we're going to answer the questions that they ask on this. So if we go back to these, we're first going to decide, is it have a maximum or minimum? So we look at the a value. It's positive, and so it might help you just to draw a quick graph. I don't need to put it on a piece of graph paper, or I don't need to have precisions. I just need to know it opens up. So now I can find everything. If it opens up, it has a minimum value. So that minimum value, remember, is the y value, and our y value is -10. So its minimum is at -10. Then we have to do the domain. Remember, the domain is always going to be all real numbers, because I can put anything in for x. The range is going to be the y values. So this starts at -10 and it goes up. So y is greater than or equal to -10. And then we have to tell when it's increasing and decreasing. So in this case, our vertex is here, so it's decreasing. And you just put to the left, and it's at the x value, and our x value is -1, so to the left of -1. And it's increasing once it gets past the vertex, so to the right of -1. So the hard part of this is finding the vertex, but we'd already found that, so I'm just going to go through these again. I would stop it as soon as you feel like you understand it. Try one on your own and see if you've got it, and then you can skip the rest. So let's go again. This one is negative, so it opens down. So if it opens down, it has a max, and that max is, again, it's the y value, so 9.5. The domain is going to be always all reals. You can just put all real numbers, or all reals. The range is your y values. Where do our y values start? At 9.5, and they go down, so y is less than or equal to 9.5. And then this case it's increasing as it goes to the vertex, so it's increasing to the left of, and our vertex is at 3/2, so 3/2 are 1.5, and it's decreasing to the right, because once it gets to the right of the vertex, it starts going down of 3/2. So hopefully this is, the hard part of this is finding the vertex, because then the rest, if you can draw the graph, is pretty easy. The third one, okay, we look at the a value, it's positive, so it's opening up. So it has a minimum. Minimum at our y value, -16. The domain, again, always all real numbers. And the range is our y values, and they increase, so it's y is greater than or equal to -16. That's our lowest point. And now it's as it comes to the vertex from the left, it's decreasing. So it's decreasing to the left of -2. And it's increasing to the right of, again, the vertex, the x value vertex. Let's do one with fractions. Nothing changes. Our a is 1, so it's opening up. So it has a minimum value. And that minimum value is, in this case, -17.4, so or -4.25 if you did that. Our domain, again, always all reals. Okay, our range is our y values. It's increasing, so it's y is greater than or equal to that lowest point, -17.4. Okay, then it's going down, so decreasing to the left of our x value, -3/2, and increasing to the right of our x value, so -3/2. So hopefully you're finding this fairly easy to do. The hard part, again, that takes time is finding the vertex on all this. So the last one, Again, hopefully you try this one on your own now if you haven't done any of the others, and make sure you get it right. Our A is -3, so it opens down. So since it opens down, it has a max. That max is at 37. Our domain, hopefully we're not missing this now, all real numbers. Our range, Y is, since it's opening down, less than or equal to our 37. It's increasing to the left. Remember, this is of our x value, 3. And so therefore it's decreasing to the right of 3. And that's what we're going to be doing on the 2 parts of the assignment today. So, our assignment is on page 61 to 62. Again, this will be in the big ideas. It's 21 to 29, the odds, and 39 to 47, the odds. So, what? I think you have 10 problems to do. So, hopefully this makes sense, and hopefully the more examples helps on this, and it'll make it clearer for you. So, good luck.